Welcome back, viewers. In today's video, we're going to be talking about the concept of move part 2. So now, if this entire subject is new to you, you can check the previous video where we did the concept of move part 1. When we talk about the introductory aspect of what moves. But in this particular video, we're going to be talking about what the relationship, the various relationships that what the numbers of moles of a given substance has with other parameters such as mass, its molar mass, the numbers of particles of that substance, and what Avogadro's constant. Don't forget we talked about that. You can look that up. Look that concept of Avogadro's number in a previous video. Now, with that being said, let's talk about the what relationship. So in this video, we're basically going to be focusing on these two. There are other relationships, other equations that relate numbers of moles with other parameters. But we're going to be focusing basically on these two. Which is what the numbers of moles of a what a given substance is given by what now the mass of a molar mass. So now let's take things slowly. So now with this relationship you can use it to handle practice problem. So now the numbers of moles of a given substance is equal to what the mass of that substance divided by the what the molar mass. And also the numbers of moles of a particular substance is equal to what the numbers of particles. Pay attention. The numbers of particles of that substance divided by what the Avogadro's constant. So now when we say numbers of particles, at this particular point, the number of particles of that substance can either be what the atom, the numbers of atoms, or the numbers of molecules, or the number of what ions present in that given substance. So let's quickly look at this. Remember, matter in general consists of molecules, and molecules they consist of what atoms, and atoms they consist of ions. Atoms they consist of what ions. So now this thing I just did here, the arranging them in the decreasing order of complexity. So now matters made up of molecules, and molecules are made up of atoms, and then ions. So now this relationship we can handle what practice problem. So now of course Avogadro's constant, let me represent it to Na. So let's say let Na, or rather An rather, be Avogadro's constant. So now, of course, we know the value from our previous video is 6.02 times 10 to the 23rd, or you can call it 602 hexillion atoms. So don't forget, let me just quickly digress a bit. So now, remember that what if we have a 12 articles is equal to what 1 dozen. So now I told you that when you have this value of a what a given substance, this you're said to have what 1 mole of that one substance. Now that being said, and with this relationship being cleared, let's go straight to handling some what practice problem. Question says, what is the mass of 2 moles of nitrogen? So from that question, we have the molar mass of nitrogen to be 14 grams per mole, and we have the mole of nitrogen, which is equal to 2 moles. According to the question is 2 moles. So now we're asked to find what is the mass of 2 moles of what? Nitrogen. But recall that nitrogen is a diatomic molecule. Remember atomicity. You can check out my other video on that. Atomicity of what? So now this is one, and nitrogen is one of the diatomic molecules. And it's always represented as N2. So now if we should do that now, the numbers of moles, if this particular chemical compound is what? True, therefore means that what the molar mass of what the nitrogen gas will now be equals to what? Of nitrogen gas will now be equals to 14, which is the molar mass of one atom. This is an atom and this is a molecule. Don't forget that. This is an atom and this is a molecule. So now 14 times 2. This will now give us 28 in total, 28 grams per mole. So now, but this is just the molar mass, the total molar mass. So therefore, recall that what numbers of moles, or the numbers of moles of a given substance, equals the mass of that substance divided by the molar mass. And with that being said, from our question we have 2 moles of what? Nitrogen. That's 2 moles of what? Nitrogen in the question. So we have 2. Then our mass, that's what we're looking for, is unknown. Our mass is what we're looking for. Then the molar mass, which is the total, is equal to what? 28. Now making mass is always the formula. Do the math, we just simply have mass equals to 2 times 28. By the time we do that, we have about 36. No, wrong. in the math, we have about 56. 56. Yes. 56 grams. 56 grams of nitrogen. Nitrogen. Yes. 56 grams of what? Nitrogen. So now, just by doing that, as simple as that, that portion of what has been solved. But let's move to the next one. The second one says, what is the mass of 2.7 moles of aluminum? So now from that question, we have the molar mass. The molar mass of aluminum to be 27 grams per mole. From that question, we have the molar mass of aluminum to be what? 27 grams per mole. And the numbers of moles was also given. A mole of, from that question, the mole was also given 2.7 moles. 2.7 moles. 2.7 moles. So now we have to find the mass. So now recall that the numbers of moles is equal to the mass of the substance divided by its molar mass. Molar mass. So now, unlike nitrogen, aluminum is not reducible, it's a metal. So now we have, so 27 still remains. So now the numbers of moles still remains 2.7 from the question, and we have our mass, which we were looking for, and the molar mass 27. You see that now? So 27. So now the mass now equals to, the mass therefore now equals to 2.7 multiplied by 27. By the time we do the math, we round up about 72. So now the next question says, what is the numbers of oxygen atoms in 32 grams of the gas? So now from that particular question, it was stated that the molar mass of oxygen is 16, while Avogadro's constant, usually represented here as Na, giving us what now? 6.02 times 10 to the 23rd. We're already familiar with that. So now, for mind you now, they're asking for the numbers of atoms. Let's take a look at that. They're asking for the numbers of atoms. So now be careful. I told you numbers of particles can either be atoms, molecules, or ions. So now whenever you get a situation like so, they ask you to find the numbers of atoms, or find the numbers of molecules, or find the numbers of atoms of a given substance, you know the relationship to use is, the best relationship to use is this one. The numbers of moles of a given substance given by the word numbers of particles divided by what? Avogadro's constant, because the numbers of particles at a particular point, that's what you have asked to look for. Now from that question we have the molar mass. Molar mass. So now let's check what we have. Molar mass. From that question we have molar mass of oxygen. Oxygen. Mind you, oxygen gas is what? Oxygen is the atomic molecule. So the molecule of oxygen gas is the atomic. So oxygen gas now equals to what? The molar mass now equals 16. That's 16 is for one atom. So now about two of it, the molecule contains two atoms. So now we have 2 times 16, which eventually gives us what? 32 grams per mole. 32 grams per mole. So that is the molar mass of oxygen. So now remember numbers of moles. Mole will now be equals to what? Numbers of particles, which is what we're looking for in this case. The particles we're asked to look for in this case is what? Atom of what? Oxygen divided by what? Avogadro's constant, which is 6.02 times 10 to the 23rd. Okay. So now we're given the mass of the question, 32 grams of the gas. According to the question, we're given the mass of oxygen is 32, the reacting mass. So just a quick note, this mass here also means what? The reacting mass. Take note of that. Can also be called the reacting mass. Now that called reacting mass over molar mass. So take note of that. So it means the mass that was took part in that particular, the mass of that atom or the mass of that substance that took part in that particular reaction. That's what it actually means. So it can also be called reacting mass over what? Molar mass. So now with that being said, we have moles here and we have numbers of particles which we are asked to look for and we have Avogadro's constant. But we only have the value of this. We have molar mass. So now, mind you, we can go and use the other relationship. This one best solve our problem, but first of all, we need to remember that. Also remember that what numbers of moles, or let's put it on this way, numbers of moles is equals to what mass, reacting mass over molar mass. Molar mass. So now let's look for the reason why we're doing this. So we can look for the mole first, then we'll come here and look for the mass of particles. Since we're given the mass to be 32, we're giving the mass of the gas to be 32, and we're giving the molar mass for oxygen to be also 32. So now 32 rather. Now 32 divided by 32, we have 1. Yes. So by the time we do that, we have 1 mole. So now, putting into this equation, our mole is 1 equals to numbers of particles, which we don't know, which we're looking for. Numbers of particles, which is what? Which at this point is what? Our atom. Then we do that divided by the what? 6.02 times 10 to the 23rd. By the time we do the math, our numbers of particles now equals to what? 6.02 times 10 to the 23rd, because we're multiplying it by what? By 1. So that's our answer. Before we look at the last question, there's something we need to note. A very important point we need to note. Numbers of moles is equals to any one of these words, any one of this expression. These are formulas for solving numbers of moles. But we can also equate both of them together. We can also say this numbers of moles is equals to mass all over molar mass, or molar mass. It can also be, so we can equate both of them together. Mass of molar mass equals to numbers of particles. I hope you can see this. Numbers of particles over Avogadro's constant. With this one, we can also solve straight. So now let's look at an example that has that. So let's look at the last example for today. Now, with that being said, the next question states that if 1 mole of aluminum contains 6.02 times 10 to the 23rd atoms of aluminum, how many atoms are contained in 0.9 grams of aluminum? So now from that question we have the molar mass of aluminum to be 27 from that question. So now on this part you can also look at it here. From that question we have the molar mass to be 27 and we have the mass of aluminum used in that particular reaction to be 0.9. That's two important points we draw from that question. So now, since we have the mass and we have the molar mass, and we are asked to find the numbers of what, how many numbers of what atoms of the aluminum will be present there. So now, of course, we also know that what now, from that same question, since they're measuring numbers of atoms, in this case again, you know that what is going to involve Avogadro's constant. So don't forget that Avogadro's constant is equal to 6.02 times 10 to the 23rd. 23rd numbers of particles. So now, with that being said, like I said, from what I wrote at the top there, I don't know if you're seeing it, but we can also equate the two equations, because these two equations, mass of molar mass, can also be equated to this because they are also the same thing. They both gives you numbers of moles. So we can say numbers of moles equals mass over molar mass. The mass is also equals to the numbers of particles. I'm kind of abbreviating them, so you have to bear with me. So now, when you have what? Avogadro's constant. Avogadro's number, okay? Avogadro's constant or number. Avogadro's constant. Now from the question we have the mass to be what? 0.9, that's sure. Then molar mass of the aluminum is 27 equals to numbers of particles, because we have to find how many numbers of what atom in the question. So we use what looking for numbers of what? Numbers of particles. Mind you, I'm beginning with very what? Writing on these words. Bear with me as well. Now particles, we have Avogadro's constant 6.02 times 10 to the 23rd. So now making it solve the formula, like I can do that, we have numbers of particles. Let me come back to this side of the board. So now, by the time we do that, we have our numbers of particles to finally be mixed. So the numbers of particles, mind you, so it's separate, continuous. The numbers of particles making a sort of formula we have. Numbers of particles, this we're going to cross multiply each other. So now we have this the time you multiply, you divide, you have the numbers of particles now equals to 0.9 times 6.02 times 10 to the 23rd divided by 27. So now that's how we're going to solve it. And by the time we do that math, we're going to have something of this value. We're going to have something of this value. 2.0 times 10 to 23rd. Numbers of atom of aluminium. Do the math. This will have as our final answer. So now with that being said, that's it for this video. I hope you understand. I hope this helps you to understand how to use this relationship to calculate. So now make sure you smash the like button and see you on the next one. Have a nice day.